So welcome back everyone. Now we have Rajitda who is going to speak on asynchronous programming with JavaScript. Rajitda, you can take over.
So, hi, good afternoon, everyone. Uh, I'm Ratati Bhattacharjee. All of you might be knowing, I'm a software engineer at Typito, and I work with JavaScript professionally. So, yeah, and even though if I do, doesn't mean I know a lot about this language, neither do I like it. It doesn't even falls in the top 10 liked languages by me. But I'll try to talk about asynchronous programming because that's one thing that JavaScript gets right is how to do synchronous programming in it. Okay. Uh, I'm audible, right?
Yes, Rajitda.
Yeah, okay, great. So I think everybody's in. But I will try to have it completely hands-on. So basically, I'll be switching back and forth between the editor and the presentation. Let's just okay, that's great. So asynchronous programming. So what's this about? So let's first talk about JavaScript as a language. And every time I say JavaScript as a language, this is my exact expression, because I don't really need to. I don't really need to explain to people that what is it is as a language is. So obviously there are two sorry, quotes given by Douglas Crockford. For anyone who doesn't know about Douglas Crockford, he is one of the primary contributor in the ECMAScript standard. So whenever we say ECMAScript standard, so JavaScript has a spec. So basically, how should JavaScript be implemented, or what functions should be there, what should be API, what should be the language constructs like if, else, whatever. So that's part of what we call as the ECMAScript spec. Who implements it and how they want to implement it, that's up to them. So there's WebStorm, there's V8, all these different engines, all for the one sake of implementing ECMAScript. So Douglas Crockford is one of the guy who actually sets up the ECMAScript and has have been contributing in it for so long. Uh, Yeah. Next is obviously let's look into his two of his thoughts. Is JavaScript is the only language that I'm aware of that people feel they don't need to learn before they start using it. So many of you who might be into web development may have come across JavaScript. And the best part is that you actually start building your web pages and start using JavaScript without even fully understanding it. And that's the beauty of this language. You don't need to understand it fully. It's not C. With C, the moment you reach the point of pointers, that you start working with pointers, you have to understand how they work, how it's working. If you do not, you'll probably blow your own foot off. It's the natural way of how the language is designed. There are several other languages also. Scala is one. If you don't understand what the language is doing, then you'll probably end up writing things that will blow up. There's another thing about JavaScript is that it's like, although over Stack Overflow and over many different polls you will see that it's popular, right? Uh, but the thing is that people also hate on it, including me. I'm not a big fan of the language because there are some issues here and there. Okay? I'm a fan of TypeScript, by the way, which is actually a typed version of JavaScript on top of JavaScript and actually compiles to JavaScript. So I'm a fan of that. But JavaScript has its own issues regarding how it handles literals or string literals, or how string literals are actually sometimes treated as numbers or numbers treated as strings. So there's like finicky things all around. But let's look into the good things about it. Is it's easy to pick up as a beginner. So today I'll be discussing about promises, right? So for example, if you have not even done JavaScript in your entire life, the script that you'll be looking at will be so easy and succinct to read that you won't have any issues to understand what's happening. Okay? Dynamically typed. So basically, type is not a big deal here. Integer, string, variables can be variable type, as the name says. Single threaded. Okay, so there's one reason why JavaScript gets all the hate. It is single threaded. So basically, when we say multi-threaded languages have a different sort of execution context. So yeah. So when you say multi-threaded languages, so there is like, we assume that there is one core, right? And if there is like one single core, and there are like your program, right? It can have multiple threads. Thread 1, thread 2, thread 3, right? And the core can actually look all of them simultaneously or switch between them. So it can actually switch, right? JavaScript is not that. So in case of JavaScript, what will happen is that this is your code, this is your program or your JavaScript runtime, and this is your one single thread. That's it. So whatever you do, you always have to do in this one single thread. So wherever you are writing any kind of async functions, never assume that it's actually getting run in separate threads. So you cannot do things parallelly effectively in JavaScript. But we will actually look at, so we will now find how we can actually do parallel things, or rather concurrently, things concurrently in JavaScript. So that's what asynchronicity is about. So remember this, JavaScript is single threaded. That is, whatever code you write, it's all getting run in the same stack. There's no parallelism here. This is one important point that you should remember when you're working with JavaScript. Again, can be used to build wide variety of things. So those of you who know, recently for the SpaceX launch, where they've sent manned mission like in the orbital, there the console was running, their information console in the spaceship was running JavaScript. So it was an Electron application that was giving all the updates. So you can see that it's getting used everywhere. The next thing is that it's JIT compiled. So if anybody's interested, they can read about it. JIT compilation is something that's not that recent. It's about 25 years old. But JavaScript started using JIT compilation around 2008. So when we say JIT compile, it means that generally what we assume is that so generally it's the assumption that programming languages, the compile one works like this, that when we say compiled, we say this is your code and it's getting translated by a compiler, right? And then you get your assembly or your target code, right? This is how generally the workflow is. On the other hand, interpreter has a different way of working. So those of you who know this, interpreter would probably take each line of your code. So one code line, well, that's a standard definition we know, code line or code function, and then turn it into something. I'm writing assembly here, but I should not. It should be actually some target code, which can be executed. JIT, on the other hand, does something different. JIT actually takes your code, right, turns into something intermediate, right, and then take it line by line, or function by line by line, or function by function, and then optimize it, right? And then we have an assembly which can be run, right? So there are multiple steps here. So this line by line idea, it comes from your interpreter. This optimization and compilation comes from your compiler. So JIT is doing both of the things at the same time. So JIT is used in your JavaScript, JIT is used in your Java, and several other languages. I think there's another language, but let me think about it. Julia, you might have heard of it. So that uses LLVM recompilation. So JavaScript, and why I actually brought this idea of JIT compilation, because this makes JavaScript fast. JavaScript was not fast. So I think it was around 2010 where it was introduced, or maybe just before that, I don't remember exactly. But JIT compilation is what made JavaScript mainstream. Okay, so let's talk about this. Something that we are concerned about today is concurrent programming and parallel programming. So what is it? You might hear people who end up using these two terms interchangeably. So the first thing that I want to highlight here is that these two are not same. Concurrent programming and parallel programming are not same. So what is it about? So you have a single processor, right? And you have an n number of tasks. They're coming in. The processor is taking each task in, executing it out, and giving the output. This is single processor and multiple tasks. And this is happening sequentially. You can see that each task is coming in, the processor is churning out the output. On the other hand, you have parallel programming. This is the traditional view of how parallel programming works. You have multiple processors, like my Intel Core i7 has 8 threads, so it has potential of running 8 code sections at the same time, or 8 tasks at the same time. So processor 1, processor 2, processor 3 all takes tasks independently at the same time. They can do that because there are 3 resources which can actually churn the data parallelly. But here comes the hitch. That then what is concurrency is all about? Well, concurrency is all about is when you don't look at the task like this. You don't actually batch the task. You don't take one task, push it in, and wait for the output. No, concurrency is when you put all the tasks together at once, and the CPU is responsible of switching between them. So concurrency actually already happens in the processor and the operating system level. But concurrency in the application level, that's where asynchronous programming comes in. And why do you need concurrency in the application level? So let's talk about this. Let's divide our actual runtimes to actually see then what's happening. So suppose if I think about the kernel level, so at the kernel level you have kernel threads. Yes, we have kernel threads. Now the thing about kernel threads is that kernel threads are managed by kernel, right? They're kernel managed, and plus kernel threads are actual assembly code, right? We're talking about assembly codes which are getting run by the raw processor. It's the processor that's looking into it. So the processor can be 1, it can be 2, the count can be n. I don't know how many there will be. Okay. At the OS level, so when I say OS level, I mean to see the user space, the space of the application level. Is they actually sometimes use kernel threads. Sometimes OS have their own threads. We call them as the OS threads or the user space threads, and they are getting mapped to the kernel, and the kernel is responsible for mapping it back to the processor. Now here's the thing, suppose this is your application, okay, this is your app.js, right? And you have some heavy compute, right, some compute task, right? Then you have some network request, then you again want to do a heavy compute. Now here's the thing, this heavy compute, this network, this heavy compute, I don't have any interdependency among them, right? Right? I don't have any interdependency among them. So can I launch them parallelly? Well, the answer in JavaScript is yes, you can launch them in parallelly, but this heavy compute task, that is something that will be running the code, this heavy compute, that won't happen parallelly, but there's one thing that will happen parallelly, it's network call. Why? Because network is basically I/O, and for anyone who might have maybe in engineering, or even if you're not, I/O is basically input output, and input output is done by your network card, right? It's done by your network card, or it's done by your disk. And network cards and disk are slow. They are slow. Like always remember this. This is the slowest bottleneck. If your application is getting slow, remember this, that chances are there is some kind of I/O in it. And if you're not doing some kind of computation, so they are slow. So if it's slow, we can basically delegate this network task to the OS and say, hey, OS, you handle it, and let me just go around and do my computation in the application level. That's the entire idea of what asynchronicity in JavaScript actually means. So we are delegating part of the operation, which actually takes a lot of time because it's the limitation of the system, and giving it to the OS, and the application keeps running on these functions. So actually, let me get back to the chat once. So is this like everybody gets what I'm talking about here? Because if you have anything to ask, please do. Because now we will go into the code. So I'm looking at the chat box right now. So yeah. Any questions? Anything that you would like to ask? I know, like I just gave the backdrop beforehand because otherwise threads and concurrency might be a little bit confusing. Now it's fine. Okay, that's great. So I hope people who do not have computer science background or maybe engineering background get to understand this. Maybe kernel threads, all this might seem the best part of the day. Okay, okay, thanks. This is the best part of the day. Okay, so here goes nothing. Okay, so concurrency, we are clear with that. So we know what async is. We know what concurrency is. Concurrency is basically thumbs up. We all are engineering students or like passed out, recently passed out, और हम लोग जैसे जीते हैं. That's part of what concurrency is all about. You keep doing stuff all. Why are subtitles on? Oh, because yeah. Thank you. Actually, it was for the other speakers. Never mind. Okay, so concurrency for simplicity purpose, for anyone if you have not still got what concurrency is all about, concurrency is what you do in general, right? So हम लोग engineering students, right? Like मैं it's been 1 year I have graduated, but what we used to do, assignment है, we have been given assignment and we don't do it. We have some other task. Let's attend to that. Why? I don't know. Like, we'll do some other task. We'll not do the assignment. At the very last day, when is the submission day, just before moment of the submitting the assignment, we do it. The task is clear, right? In the end of the day, there's just one person who did it. कोई senior आके किसी senior ने किसी junior को तो नहीं दिया. देता होगा, I don't know. That's different thing. But in the end of the day, like if you're honest, then you would be doing your own assignments. So the thing is that if you are just one person who did your assignment, right? And you are also the other person who actually went out and had fun in the other time. But you are doing both of the stuff, right? It's just that when the assignment was given, you did not do that at that time. You did it some other time, back, किसी बाद में, before actually submitting the assignment, you did it. That's asynchronous programming. That is the very essence of what asynchronous is. So I hope asynchronous is clear. So yeah, let's move on. Asynchronous using callbacks. So now I will be going to the editor and everybody needs to tell me whether they can see the editor or not. Like, is it visible? Or otherwise I'll have to change the font size, color. Okay. It's most like John Wick with Java. Okay. Okay, so the first thing is we'll talk about callbacks. Okay, asynchronous using callbacks. Callbacks is a good oldie fashion of doing asynchronous in JavaScript. Now, I'll legit got confused. Just a moment, right? Just a moment. Okay. Oh, got an important message. Okay, so it's visible. Let's try. Okay, so callbacks. Let's look into it. Let's look into the code first. So this is JavaScript, and this is a JavaScript function for anyone who does not know. So let's just give it them context, because it's not necessary that you have to know JavaScript. And it's also necessary to do asynchronous programming, like only in JavaScript. You can do it in a lot of different languages in a lot of different ways. Okay. So this is your function. Do something. We pass some value and we pass a callback. So what is a callback? Let's look into what a callback is. Okay. See, a callback is just a function. Now, this is actually a shorthand notation of writing a function. So let me actually show you what we're doing here. I'm live coding, by the way, so yeah, there might be cases where things just simply break. I don't know why would it, but you never know. It's live coding, right? Things can break. Okay, so go through it again. This is a function. Okay, we have two values here, one value, one callback. This is one callback, and you can see that I'm actually calling the callback. This is the assumption that callback is actually a function, right? Do something, I pass a fun. What is fun? Fun is another function. This function actually takes a value and prints it. Okay, so let's run it. Hopefully it will run. Otherwise, I'm streaming this. And yes, that's not embarrassing. Yay. Okay, so I hope everybody gets what callback is, because this is like what do you say, the proto-asynchronous doing this. Because why proto-asynchronous? Because for many of the file system calls in Node.js or even in DOM manipulation, there is an HTML on the front end. When you manipulate DOM, when events happen in DOM, your functions are actually getting called like this. So in DOM, you actually end up writing something like this. Wait, actually, I can show you right here itself. I should not be opening it like this. Document get find by ID. I don't remember actually. So it's just actually show it time. Let's take. It's generally like get event listener, and then you like specify the event, and then you give some callback. Right. So this is a prevalent concept, a prevalent way of programming in JavaScript when you are programming in the front end. You generally attach a listener. It's what we call as listener. We'll be actually getting to this point here when we are in events. I'm actually spending a lot of time here because a lot of people may not be introduced with the concept of Lambda. By the way, remember this. I might start calling this as Lambda. Also, you might have noticed that I'm using a lot of Python these days. That's why the hash. Yeah, they're called Lambdas, Lambda functions. Or in JavaScript, actually, they are called arrow functions. Okay, so let's not spend more time here. Let's go to the fun part of what asynchronous can do. Okay, so let's change the function of do something, right? So what do something was doing is simply calling the callback, but let's do a set timeout. So in JavaScript, as we have already talked about, that everything is single threaded. So if everything is single threaded, that means there has to be one call stack. There's only one call stack. So for anyone who does not know about call stack, whenever you call a function, right? You call a function, there is some memory allocated, okay, which is used for maintaining the code, the variable, and not the code, but mostly all the variables and whatever state change is happening. Okay, so there's some memory always allocated. And remember, whenever this function ends up calling some other function, fun1, right? Fun1. This stack, basically, it's like the best example. If anybody does not know about stack, bargi mein agar bartan rakhoge, you try to put some dishes on top of each other. That's the idea. Like dish, another dish, dish. That's like a lot of dishes. So that's the idea. So consider each dish as a function call, and the function call keeps stacking on each other. That's it. And after one function is done, it's simply popped off. That's the actual language of what you say. It's popped off the stack. Good. So since we are talking about that JS is single-threaded, so that means there's just one single stack where everything is happening. Now let's look into it. What actually in the stack was happening. So in the stack, do something was getting called, right? When we actually call do something, right? Do something ends up calling our callback. So our callback was whatever function we have specified. Our callback comes in, does our job, and then it gets popped off. And then again, do something also gets popped off. Now what would do something with delay do? Do something with delay will actually set a timeout. So what a timeout is basically the we specify some buffer time. Show it's used. Specify some time. Let's see time. And after that buffer time, whatever I have specified here will be executed, right? So let's see how this one works out. Okay. Let's see how this works. So this time, do something with delay and do something with delay. And we actually tried it 2 times with 3000 milliseconds. Actually, it's millisecond, by the way. Remember this. So whenever I say 3000 seconds, sorry, 3 seconds, it actually is 3000 milliseconds. So in JavaScript, we actually give the input as as milliseconds. So always remember this. So I'm just using thousands. I've not changed the function much. Okay. So is that, I hope everybody gets the idea of what's happening till now, because after this it will like shoot up immediately. I hope everybody understands the callbacks functions and functions. Difference between callback of function and function. Okay, good question. By the way, someone from core team, if they can actually, since I'm not looking into the chat all the time, if they can actually keep telling me if somebody is asking any questions. Okay, I noticed this. Yeah, so Meghali Nandi, your question is between callback of function and nothing actually, because here's the thing about JavaScript is that this is actually a very fundamental concept of also is that it's not something which yeah, function as first class members. Now we are actually going a bit into the domain of functional programming here, but I want everyone to remember this basic concept: function as first class members. So what is first class members? If you actually do a Stack Overflow search right now, you might get this in the top answer, is that when you say first class, it actually means stuff that you can, values that you can use, values that you can use. So a function is no more just a description of your code. So if you think about C++, if you think about Java, if you think about C, whatever it is you have programmed it, that doesn't consider a function as a first class object. In that, a function is just a description of what to do. There are two kinds of code, right? Remember this. Code is two kinds. One is description, what to do. The other is the code as an object itself. Okay, so what's that? In a language like C or C++, the code itself is actually a description of, yeah, this is what you're supposed to do, like do it. And you cannot exactly reference to code. Actually, you can do that. There's something called as function pointers in C and C++, but we will not go in that direction. But the thing is that you cannot consider a function. It's not possible in C or C++. But on the other hand, in JavaScript, you can. You can pass around functions. So as you can see, I've actually created this fun. Fun is a variable. Actually, it's a variable. Its type, you can see its type is what? It's a arrow function. It's an anonymous function. It's a lambda function, which takes in value of any type and returns nothing, because it simply just do the whole lot now. So does this clears up, Meghali? Because it's actually a very nice question. What's about callback functions? So does that clear up? Yes. Okay, so I think we are done with the callbacks for now. The final test that we will be doing, the crux of asynchronicity comes in, is that why I have been like ranting about asynchronicity all this time. Do something with delay. We have seen already that it's what it does. It gives a delay of like 3 seconds and then like prints something. You guys want to see it again? So here's the output. Okay. Now let's actually comment this out. Okay, and measure it. So we will do the same thing, right? We'll do the same thing. Just I want everyone to look into it right now. This is measure time async. What it does, it basically does the same thing. It actually calls onto the value. We're doing the same thing. Remember this. There's just one extra step, is that we are actually calling another function calls. What this calls do is actually something that is run only when the value of this inner value, sorry, the value of this inner variable is 2. Okay, so because we are actually calling it 2 times, right? So we want to actually measure the time when both of the function calls have finished. The one thing I want everyone to note is that both of these do something with delay will be running for 3000 milliseconds. Okay, remember this. I want everyone, because I'll be asking this on the chat box. Okay, and let's look into it, that how much time does it take. Okay, so here's the question. We passed in measure time async as 3000. Both these functions were running and they actually ran with a delay of 3000. So the question is, why both of them, like why the execution stopped after 3000? Shouldn't it add up? What I'm getting it wrong? Like I'm actually willfully getting it wrong. I want the audience to actually answer this. Is that what I'm actually willfully getting wrong? That shouldn't the answer be actually 6000 or something around 6000, because both of these functions were actually getting called with a delay of 3000, right? So yeah, it's up to the audience now. So I'll just wait for like a minute and like async calls. Yeah, that's actually the answer. They are async calls. So effectively, what's happening is that whenever you're calling this do something async, this is actually launching a sort of a listener, okay, or sort of a timer, right? Do something, you call it again, it again launches. Actually, there is a global timer, and it actually attaches one more function to it, right? And whenever the time happens, whenever it's actually 3000, when it's done, since you see they are actually happening on the same time, the moment you call this, do something delay, the global timer, the function, this fun or this lambda function is immediately attached to the timer, to the global timer. And when time is right, when it's about 3000 milliseconds, that's when all the functions which were actually set up for that particular time gets triggered on. And that's the essence of asynchronicity here. Is that in this case, this was time, right? In this case, we're using an artificial delay. It's offset timeout. But okay, guys, are you having some network issues from my end? Like, is it getting transmitted properly? You're getting my feed, right? Okay. Okay. So I hope everybody understands. So now what happened is that currently we're doing an artificial delay. This one is an artificial delay, but the same can happen with a network, right? So instead of a set timeout, this can be some sort of network request. This will be a network request. And only when the network request is done, okay, so it's something like network request, and then you pass in the callback, right? You actually pass in some other values also, maybe, right? And only once you're done with the network, after finishing the network request, your callback will be called. So you see, your code does not have to wait for the network request to actually finish. You can go ahead and do other stuff. Okay, it's proper. Okay, so I think you now it's more clear that what's happening here is that you have to wait for any kind of IO. I'm right now using the set timeout to emulate the IO, but again, coming back to the point, I'm trying to reinforce it. Is that your code does not have to wait for IO anymore. So the network request can look something like this. This will be time taking, but again, because we are doing it asynchronously, they both will end up getting executed at the same time. Okay, and that's why we did not got a delay of 6 seconds. We actually got a delay of only 3 seconds. Okay, with some extra milliseconds. One more fun fact: don't actually rely on this. JavaScript timer is actually based on the number of ticks. Something with known as ticks. You can actually read about it. I want everybody to actually read about it. It's something called as ticks. Okay, so JavaScript actually measures its time as ticks. Now let's come back to the asynchronicity again and single threadedness. And I want everyone to see it very minutely and understand what's happening. Okay, so now I will do something, and I want everyone to predict what will happen. So this is your measure time. So let's I'll open it up properly so everybody can see this. So this is your measure time, right? Just copy this code. So the question is, what do you think this code will do? It's the same code, but I have actually make a minor change here. The minor change is being this while. Okay, so and I think everybody understands this. That like what's happening here is that it's looking for it should be 0. Let's try this. Okay, so I want everyone to predict whether this will work or not. It's to the audience. I want everyone to predict whether this will work or not. I hope everybody understand what it's doing is that it's trying to measure the time here, and each call is incrementing the value of calls. When it is 2, because I'm actually waiting on it. When it's 2, it will actually go ahead, and then it will do a console.log. So everybody like try it out. Will this work? Call will never be 2. Okay, and actually the answer is actually right on that, but yeah. So any reasons for that, Nigali? Like, do you think that it should be a reason? Like, I'm actually giving all the reason, and it's something that actually plagues a lot of JavaScript code. A lot of beginners get it wrong at the first time. Like, I also got it wrong when I started out. So yes, everybody gets it right. So it's kind of a rite of the passage. You have to go through. You have to get it wrong. Okay, so I won't delay much. Let's execute it and see what happens. It's stuck. The program is stuck. Now, let me explain what's happening. Let me explain what's happening. And it's very, very crucial to asynchronous programming and the single-threaded nature of JavaScript. Is that when you call your do something and do something async, we've already talked about that there is one timer, some sort of global timer, and there is a function getting attached to it, right? Again, you call do something, and again the same operation is done. But remember this: the execution has not ended yet, right? And this is actually triggered for the milliseconds 3000. When you write this while loop here, calls equal to 2. This code, this thread, basically in the call stack, right? In the call stack, we are stuck here, right? We're stuck here. We cannot move because this while loop is not getting satisfied. Since it's not getting satisfied, we cannot move out from here. And because we cannot move out from here, this function is never getting called. Sorry, this particular function is getting never called. Like, yeah, timer has already realized that it's about 3000, but the problem is the event loop hangs on the thread. It cannot move ahead. So let me show you from the, and this is one more thing that everybody should know. I don't use it much. I don't use it, but everybody. Let's do this. You can see in the callback stack. Wait, actually, let me stop this and then let me give a breakpoint and then start. Yeah. So as you can see, we are never reaching this calls point, right? We were never reaching this. So it's kind of stuck here, call stack. Why? Because of this while loop. Because there's only just one single call stack, right? I also would like to actually share another thing here. I don't know whether it's there or not. it's so while that loads up, again asynchronicity, while that loads up we can skip ahead. Let's stop this and let's move ahead with promises. Okay, so I hope everybody understand what happened here is that you were actually blocking your main thread. I mean, I was blocking my main thread. So on to promises. So we'll ramp up the difficulty level here a bit. Before I do so, please do let me know if you have any other doubts or anything. Please do let me know. Uh, Guys, anything you want to ask? We're just about 13 participants now. So this is one small article actually I wrote. So you can actually check this out, how you can actually end up blocking your main thread. So moving on to promises. Yeah. So let's look into how promises are utilized. So what exactly promises are? Node promise.js. So you can see that we are using promise.resolve and promise.reject. So promise is basically an object, like a class object given by JavaScript to actually enclose any kind of future execution. So instead of using callbacks, you can use promises. Promises have this what we call as a then and a catch, which is much more easier to trace because you can then what you do is that promise.resolve, you found the secret and promise.resolve. So actually let me execute this and show you. Successfully it was message. So do something 42 actually gives the successful message, promise.resolve, and promise.reject is basically used for errors. So if I actually do 43, we fail. Okay, so that's it. So promise.resolve, promise.reject. Why do this? Because we get this then and catch. Then we get a more better control of when the error is happening, when it's successfully getting executed. Then and catch and promises is actually effectively made for this purpose only. Okay. Yeah. So any questions about promises? Because actually I'll just show around that how promise can help us, but otherwise promises, that's it. Like promise doesn't have anything much in it. Like otherwise how we can use promise, there's a big part of it, but promises doesn't have anything much in it. They're just callbacks and like nicer looking callbacks. So yeah, questions, anything from the participants? Okay, so questions then. Okay, I'll move on. So I'm not doing a callback here. Oh, I'll just highlight one more thing. So you can see that do something is actually a function which takes any value and returns a promise object. Remember this, I've actually said promise is an object. Now I can do a do something and this value will be, wait, it's not actually predicting it properly. That's funny. It should, the value is actually a promise because we have already seen here it's a promise of string, and then we can on the value we can actually do this then and catch. Taking this further ahead, we can now try and do this, right? Just wait, do something async sequentially. Just wait. Let me just comment things out. Okay. So let's look into the code first. What happened? So what's happening is that we try with do something 43, and we know it will error out. That is, it will actually reject the promise. So we shall try again with 44, do something 44. Then we again do a catch on it. So when I say this catch and then, remember this, then is when everything is fine. you do a then on it. When you know something will be erroring out, like it will give an error, then you do a catch on it. Okay, so this is what we call as promise chaining. So if you see the comment, we let it chain it up. Okay, so do something, then again do something. At 44, we know 44 will error out, so we actually do a catch. So you can actually write it like this also. Dot catch, dot catch, dot catch. This makes more sense, I hope. So you can again call do something. This time 42, yes, we got it right. So you can see that yes, we got it right. Let's test it again. Okay. And then we test it again, 42. We know 42 is the answer. So any doubts with this? Like, because promises might be new for anyone who is doing JavaScript for the first time. Any questions, anything? Like I'm waiting on the audience for this one. Let me give, I'll give 1 minute. So take your time and think if you're clear with the code. Just show it up there. All good. Okay, that's good. It's all good, and all good from me too. Okay, great. Then, since you understand promises, let's level it up and go a step ahead. By the way, all this code is available on GitHub, so you can always execute, figure it out what's happening. Okay, so let's look into do something async. So till that point, actually, we were already doing asynchronous things asynchronously, but it was not really async. Why? Because like we were just immediately returning everything. Right now, we will add some delay to it. So set timeout. So whenever we get 42, it's you found secret. It will be rejected when when it's not 42. So it's actually from the Hitchhiker's Guide to Galaxy, if you know about it. Yeah, the answer is 42. Universe is vast. Okay, so we try to do this. Do something 3042. Right. So let's try this. Let's see whether something. Okay, that's great. Let's call this again. So as you can see, it waited for some time and then it printed, we have a sync number, you found secret. Okay. Now let's chain the call out. So remember this particular code, we're chaining it up, right? So let's chain things up sequentially. So we are actually calling, we have written a new function called sequentially. And we have sequentially, and sequentially basically encloses all our activity, right? So let's look into it, what happens. So do something 3000 with 43. 43 will fail. We again try with 44. We again try with 42. This time we are successful. So we just retry it. And then at the end, we just print the amount of time taken. Let's see whether it executes successfully or not. Okay. Wait. My bad. Okay. That's gonna take some time. Wait out. Wait for it. And yep. So it took about 12 seconds. So I hope everybody understands why it's 12 seconds, because you can see it's been called 4 times for 3 seconds. So 3 by 4, 3 into 4 is 12, right? So yeah, so it took about 12 seconds. Now the question is, can we make it any faster? Can we, like, come on, it's asynchronous programming, right? So, and it's just like calling a function when the right time hits. And plus we're doing a search. We're trying to figure out which number will give the secret of the universe, to exaggerate. So why do it sequentially? Why not do it parallelly? So here we bring in the parallel execution, that is promise.all. So we're not exactly doing parallel execution. What we are actually doing is creating multiple promises, multiple callbacks, and attaching at the same point, and then waiting on it. We're waiting on all the values. So let's look into how it can be done. So do something 3044. We see that, oh, catch, it won't work. It's the last resort. So let's do this. Let's do a search, a linear search. Okay. Now, if my math is right, if I would have done a sequential linear search of 3 seconds for 42 times, so that's like about 129 times. Is that? Wait, 126 times. Yeah, my bad. So 126 times. So 126 seconds I'll have to wait, right? But you will see that's not the case. We are here. It was sequentially happening. Remember, this is sequential. Even though you're using promise, even though you're doing asynchronously things, but you are actually executing them sequentially. Now we will execute them parallelly. So we take a list. For you who don't know, it's just a list or array, all promises. We start pushing in the promises, right? We start pushing in the promises. Each promise, if it's successful, will return a state, which is true, answer, and the number, which one actually satisfied it. If it doesn't, if it fails, it will return the state false, the answer, and the number. So remember this, all promises is just a list of promise. What it will return, this do something will now return a promise.all. So as I've written, our savior for pseudo-parallelism, promise.all actually encapsulates all different calls from promises and then returns them at once. Okay, so promise. So for example, if it happens that in all promises, in the list of all promises, if one of the promise fails, even if one of the promises fail, this promise.all will actually error out. It will give an error. That means you will actually have to handle it the catch. Because of that, I'm actually individually handling these promises here inside this. You can see this is catch, this error, then that's why I'm handling it here, so that when I do a promise.all, I know promise.all will not fail, will never fail. That's why I can do it then directly. Now let's see how much time does this one take. Okay. If my hypothesis is right, did not take much time. Yeah. You see, it took about 6 seconds. Half the time that it took for this one. So I would like people to give some comments, because the first time that I was able to achieve this, it blew my mind. I like obviously like when I was able to do this, like when I learned this, like my mind was totally blown off. Like, yeah, I've learned asynchronicity, because this is what the concept of asynchronous programming in JavaScript is. There is no parallel execution. You're not executing parallelly, but you are giving up the task at once. Like, go away, all of you, take your tasks. When you're done, come together at once. So, yeah. Any questions on it? You may be feeling like after mad. What? questions, please. We can like keep this for the after session, because these sessions are getting recorded. Any questions? Anything? Like advice getting what asynchronicity is? That's great. I mean, like it took me about a year to understand. Yeah, I mean, like I've been working with JavaScript for a while, and it took me some time to actually understand asynchronicity. Like I used to think that whenever I was attaching a listener, it was executing at that very moment. That was a long time back. Okay, so if everybody understands this, then that's great. Like you understand that we are actually having multiple promises, we are clubbing them together, and we are like shoving them off. And then when they all are done at once, that is promise.all, when they all are done, we get the final value of all of them. We iterate through it. For each is for iteration, right? We are iterating through it, and then we get the output. Yeah, at 42, the answer is the number is 42. It took about 6 seconds. Okay. Okay, so next thing is async await. So you might have seen promises, and I was reading then catch, then catch, then catch. Like it becomes like what you call this is spaghetti. There's so much then catch, and it's hard to actually trace the. Let me tell you a secret. I've seen a lot of these code in production also. People like this then catch all the time. So it's kind of annoying when people do this when they have the beauty of async await. So why it's beautiful? It's beautiful because it's like this. It looks like this. See? It's the new code. Async await. So what's async await? Await is basically you can wait on a promise. So the fundamental idea is that, okay, here's the promise. I use the await keyword, and this statement will wait. So this is actually synchronous. Let me write it down. This is synchronous. this will block the code. This will block your what do you say, the thread. Okay, so if you actually put a while loop here, this will block. Remember this, it will block. Okay, so let's execute this and know it once and all. The code here is actually same as this one. Okay, so you guys can like just check it. Async await is just a syntactical sugar, basically JavaScript again in its own way into the same code that the promises return. So if you are using promises, then you can use async await to make your code look better. It's just better for your eyes, nothing else. Like your code remains same, right? It does the same job. So node async wait.js. Trying to find the answer sequentially. Let's hope it takes 12 seconds, otherwise it will be embarrassing. Yep. Okay, it was embarrassing. Okay, we know why it happened because there are only just like 3 calls. So because I have reduced 1 call, so yeah, there are 3 calls, and hence it took about 9 seconds. So everybody understand this? What's happening here? So async await. So we covered out callbacks, we covered promises, we covered async await, the beautiful way of doing promises. So any questions, anything? We are kind of like I'll be finishing it up in a moment. So we'll look into events. So yeah, any questions on this till now? I'm looking into the chat right now, so you can put up any questions you have. Okay, so no questions then. Yeah. Okay, so the thing is, we have covered a lot. Asynchronous using callbacks, any better way to write this, promises, right? We've covered our promises. But, well, the thing is that what else can we do with asynchronicity, right? So asynchronicity is all about callbacks, and well, JavaScript does it through callbacks. So what else is there in async programming? What other construct is there that we can actually use? So one of the fundamental things that actually lot of the Node.js APIs use, a lot of the JavaScript API also uses. Most prevalently in DOM, it is used in domain object manipulation, like document object manipulation, not document object manipulation, as in HTML, CSS when you're writing JavaScript. This is all the time used. Okay, so like you actually get an element document.get element by, and then you add an event listener. This is what you're doing actually. You're adding an event listener. So let's see what we can do here. So since I'm actually executing in Node.js, that's why I have to require this in I think front end. This is available right off the window object. So we create a new event emitter, right? And we add a listener to it. So listener is happen. So the event is happen, and we actually do a callback. So we give it a callback function. And what will that callback function do? So it will say we will start printing, and it actually repeatedly print. Event okay. Yeah. So let's try it. And also, after setting up this event listener, we actually emit this event. So there's just only 2 things. Actually, the API is much larger than this, but event listeners are effectively used like this. That you set up an event listener, you give a callback to it, that callback can do anything. And on some other end of your project, in your different section of the code, you will emit this event, right? From this particular variable. You'll emit this event. So emit, happen. And then this particular code will start. So let's start it out. Events, yes. Okay. We can also do this. Let's, oh my god, set timeout. You understand what's happening. Let's do it after 5,000 seconds. Oh, sorry, 5,000 milliseconds. and console.log कितना time लगेगा? Yeah, for anyone who do not understand कितना time लगेगा, it means how much time will it take. So yeah. So after 5 seconds, your event triggers, you will start printing an array ho gaya. And after every 1 second, it will keep printing array ho gaya, like that. So that's because I'm actually using the set interval. Set interval actually basically calls your callback again and again. Just that's it. So yeah, that's event emitters. Event emitters is widely used. So if you have attended the first session of Himshikar Gyan, then he might have been talking about observer and observee. It's what we call as it has a proper name. It's called functional reactive programming, FRP, or functional or reactive programming. Sorry, functional reactive programming and reactive programming. It has a nuance difference, but in general, we actually do only reactive programming. So observer, observee, those things are internally already supported in JavaScript like this. So we use some kind of libraries to actually wrap around these things and then do it. Okay, but like we already have this. So you can see that this is my what? This is my observer, right? This function gets called, and this is my observee. Basically, this one will trigger. This one will tell the observer, hey, something has happened, and then you do it. Your observer is responsible for executing it. Understood? So I hope this makes sense. That from the I'm trying to connect it from the morning session. Thanks to Himshikar again to actually highlight it. I don't have to talk about observer pattern anymore. Okay. So yeah, any questions? This is the last topic we'll be discussing about streams. After that, we'll be done, and then to the end of the session from my end. So yeah, any questions? Anything any doubts? I hope everybody was able to understand what event is. You add a listener, or as in effect a callback, and then you just simply delegate it, and it will run whenever the event happens. The event is basically event happens and something gets called. That's it. So that's one way of doing asynchronous programming again. Any doubts? No doubts? Okay, that's great. No doubts. Okay, so I will move on to the last point. Let me go to the slide. I was going to do async programming. Event is cool, but what are blocking system calls? Now, this is the most important part. If you are actually working with backends, this is definitely important. Is what about system calls? So when I say system calls, I'm talking about file streams, file stream writing, network stream writing. Actually, I should not use the word stream here, just like file writing or file reading, reading from the network, writing on the network IO. So these are generally blocking. Effectively, actually, these are blocking. So whenever the operating system, whenever you call the operating system to do something like this, the thread which operating system uses for doing this is actually blocked. Why? Because it's waiting for the operation to end. Let me show it here. So you have your function, right? And you call it, and it's supposed to write on a file. Write on file. Now, write on file is something that only the operating system can do, right? You basically call the OS for that. OS, do a write. Do a write. Right. Now, what happens is that OS will actually block your thread at that point. Yeah, your thread will be blocked. So, how do we mitigate that? I cannot have my JavaScript already single thread, right? It has only one stack. So, how can I mitigate that? Now, this is mitigated in different way in different environments, but in Node.js, remember this, in Node.js, this is only for Node.js, I'm talking about in terms of Node.js, because Node.js is the only variant which supports reading from file. Browser, it does not, as of recently, this is for an update, like anyone update, that Chrome is now supporting reading the system files from inside the, okay. This is very recent, just like a week ago. Maybe it was updated in the Chrome. Maybe in the next 1 year, Internet Explorer might get it, or Edge. Yeah. Back to the point. So this is I'm talking about in terms of Node.js. What Node.js does is that Node.js something we call as the holy event loop. Actually, not just Node.js. Almost every JavaScript runtime has the holy event loop. Okay. So when you call this function, it actually asks the internal what we this is what it actually uses. There's a thread pool. Okay, so the JavaScript runtime somewhat looks like this. JavaScript runtime looks somewhat like this. This is your event loop, which can be done using libuv. In browser, it's done using lib event. These are C++ libraries. You can actually explore those. So this is your event loop, and then there is a C++ thread loop. Thread pool. I don't remember what it actually uses for this. We have researched it on it. Yeah. So when you call this function, right? So it delegates this OS call to this thread pool, and a thread is initialized, which does the reading. So now it actually does the transaction of reading from the disk, and your function does not have to wait for it. So your application will no more wait on it. Well, it will kind of wait on it, but basically the stack will not be filled with the same thing. Your code can keep going on and executing, right? So that's the idea of how async happens on backend also in Node.js context when you're reading and writing in the file, is that you give it to the operating system. The operating and not, instead of directly giving it to the operating system, you have your runtime environment. In case of Node.js, you're actually giving it to a C++ backend. Okay, it's already inside Node.js, which has its own thread pool. So when I say thread pool, that means it already has a lot of threads, basically worker threads, which just simply takes a task and executes it. So you take it, give it to it, and it executes the back. Like it doesn't affect your actual running code. So when the task is done, it reports back, and the event loop again picks up from the function call. I hope that's clear, because let's show this in the code. How is this done? So here's this. Okay, so you can see we have this. We have created a read stream, callback.js. So you can actually read it directly also. Like let me show you fs dot read. You can see there are two things. There is read file. There is read file sync. There is read sync. So basically these are synchronous read. If you don't want that, you can also take the read file, which actually takes a callback. You can see here callback. Okay, so it actually returns the data only when it has read fully. But I'm going to use streams. Why? I'm going to show you in a while. So we take stream of which file? Callback.js. This file. Okay, so callback.js, and this is the read stream. That is basically we are reading from the file. This is write stream. We are writing into the file. Copy.js. So basically we don't have a copy.js. I think. Okay, let's remove this copy.js because there will be confusion. We're done, and yeah. So after reading it, we are going to write it. Okay, we haven't written it yet. Here is it. So code file.pipe. So what is pipe? For anyone who's into system programming, this is not the same kind of pipe, or maybe it is. It's up to you to read, but it's not. Okay, so you have your stream, right? This is your reader stream, and this is your, my god, my handwriting needs improvement. Writer. Okay, so reader is pointing to some file, and we all know what's happening in between. It's getting run from the C++ to then coming to the JavaScript context. Remember, there is one C++ context happening in there, right in between. And same here also, C++ context. There is a Node.js environment context, and it's getting written. Pipe is something that our good buddy JavaScript gives us to actually send in the input output. So basically, you see, this stream has a method called stream.read. Let me show it here. So you can actually do this. Code file dot. See, you have this read, and I think you do not have write. You see, you do not have write, but out file should have something right. Oh, you see, you have write functions. So you can actually read and write, but why do it manually? So JavaScript actually gives you this pipe function to do it, and it all happens asynchronously. Again, back to the same point. It's all happening asynchronously. So let's run it. Streams.js. Oh my god, what just happened? Oh, console printer is not defined. Who's asking for the console printer? Oh, oopsie. Out file. My bad. Okay, so let's do it again. Oops. So you can see the transfer started, transfer then completed. So we have actually attached a event listener on finish. When it finishes off, just tell me transfer is complete. So there was no copy.js. Now there is. And what is copy.js? It's the same as the callback content. Same content. Now there's another thing that you can do with streams, as that's the good part of it. This is the good part. Is that you can attach transformers. Not the Michael Bay one or the Hasbro Toys series, and something that transforms your data. So you can see that at this, let's look into this stream.transform. So radical object mode true is basically like sending your data in a format that JavaScript understands. That's it. It won't send you binary data. That's for that. And this transform does nothing. It simply takes in the chunk and it sends in the chunk. It has a transform function that we have to implement. Console.log. And this transform is actually I have implemented to actually print it on the console. Okay, so let's see how we can use this. Codefile.pipe console printer. We just like pipe it onto the console printer, and then what we can do, we can again pipe it to the output file. Okay, so like let's do this copy.js. Okay, and then when it's done, transfer complete. Let's run this code so that you understand it better. Oh my god. See, it printed it out. It also created the copy.js. So you can create your own stream also, your stream transformers also, which can actually does stuff. So this is one like basic example, but you can also do this. You can have this as an async and then do some network IO here, which can add more data to your file. Right, and then actually pipe it onto the output file. So you are effectively transforming your file, and all this is happening asynchronously. So you can go ahead and do more stuff around here. So that's it. So yeah, on an end note. So this is your this is what I was talking about, the event loop. So you can see that the first thing that the event loop always looks at is run due timers, call pending callbacks, then idle handles, poll for IO. That is, we're talking about network IO, disk IO. If there's a bold wrong, all the stuff that I'm talking about. Run check handles, close handlebacks. So I want you guys to actually explore this on your own if you want to. Yeah, and so that's it. Yep. So yeah, that's it. So what we covered about callbacks. We talked about async await, event-based communication, streams, and piping. Something to explore on your own. I want you guys to do that is async generators. I was thinking to explore that to like talk about it, but it's actually the same thing. So you'd actually pretty much pick it up on if you are comfortable with asynchronous programming, which I hope you are, because I've been speaking for a long time. And
Rajita,
yeah.
There's a question for you on the chat.
Yeah, I'm done. Oh, sorry. Benefit of transform over async stream of data. Oh, there's no benefit. It's more of like you have your. So let me show this. Is that you want to pipe? So earlier, what you can do is let's get rid of this. Let's do this. Okay. So this is just simply taking your code file and you're just outputting it into some other file. While doing output, if you want to make some changes into it, So in this part, what I'm doing, I'm just simply console.logging it. But if I want to make some changes, so let's actually make some change. Let's make some actual change instead of just doing a dummy console.log. Chunk equal to chunk dot to. Wait, I completely forgot the callback. My bad. See, even we keep forgetting all the time. Do uppercase. Let's do uppercase. Hopefully it should run because it's under the encoding is right? It's UTF-8. It should run. Okay, so let's try this, and I think this should give you a good understanding of it, and hopefully it will work. So I am assuming that right now the output that we have has entire code in the uppercase, which is useless but good for sure. Everything is in uppercase. See, so I hope that clears out that why use streams or why use this kind of transform. Makes sense. I hope this makes sense. Yeah. So you can actually have multiple transforms in between and have multiple files transformed at the same time. Why? Because, well, again, asynchronous. जिसका data पहले read हुआ, whichever data gets read first, that will be get transformed and will be written first. That's it. We are not gonna wait for anyone. You can like launch multiple such like events like this, like this, like this, like this, and this all will happen at the same time. As a matter of fact, let's do it. I don't know what will happen if we try to do this. I don't know what will happen. So, yeah, maybe the hell is opening up. Okay. So let's see what will happen if we do this. I don't know what will happen. Copy.js में क्या है? It become larger. Okay, so everybody was writing on it. Yeah, you can see it happened so fast. Everybody was writing on it, and everything happened parallelly. There's no like it. कोई भी किसी के पास भी आ रहा है. So yeah, async writing is possible using transform. Yeah. So when you say async writing, it's not exactly async writing. Basically, whenever the data is ready, only it will be piped to the writer. Before that, it won't be piped. It cannot be piped, right? The data does not exist. So this is what the asynchronicity comes in, is that when the data is available, you transform and then you pass on to it. Now, as long as the data is not available, so for example, for number one, the data is available, is immediately getting transformed and written. But number two is waiting on the data. Number two, now data is available, it gets written and it gets transformed and written immediately. So asynchronously comes in form of whichever is getting read first, and whichever is getting read first, that one has to be transformed and then written back. That's it. That's the whole idea of it. Whichever we gets the data first. So yes, async writing is possible, but async keyword, I think maybe this function, I'm not sure whether we can use async here or not. I think we should be able to use async. But effectively, whenever you call the callback, that's when the function is done, right? So remember this, in the transform, you have to do the callback. So this callback itself can be asynchronous. So you can like take a promise, some sort of like a promise, right? And then promise, and then you can have like उसके अंदर कहीं डीपली जाके वहाँ पे रिजॉल्व कर देना प्रॉमिस को, और उसके ऊपर कॉल बैक को कॉल कर देना. You can call back somewhere deeply inside the promise. That's it, and that's your asynchronous program inside like the transformers. So I hope this was like you guys got to learn something, because yeah. Also this is my first time talking about this topic. Generally I talk about machine learning and stuff, but like really about these kind of stuff because I actually like programming and like programming constructs, to be honest. Definitely I like to talk about parallel programming and the various way that programs can be organized, design patterns. So yeah, this was first time me talking about stuff like this. So if you like it, do tell me, and yeah, you can keep asking questions. Chat is open, so I'll stop my presentation now.